Let's move on to the second step. We are about to start the election of the root port. First note. The root port is to be selected on non-root devices. That is, there is no root port on the root bridge. All ports on the root bridge are designated ports. And you have to choose the root port on the non-root device. What port to choose as the root port? You need a measure. In all ports on non-rooted devices, we want to choose a port closest to the root. We also want to compare several parameters. There are 4 parameters to compare. The root port is actually. The machine is connected to the nearest port of the root bridge. Only one root port on each switch. Except for the root bridge. Each device has one and only one root port. Let me draw a picture. I first draw 3 devices. I label them. This is device A. This is device B. This is device C. They are connected to each other. After the connection is complete, we're going to start the election now. Assuming the root has been chosen. Root is device A. We manually set its priority to 0. It is root now. No doubt. Between 2 other devices. Carry out some other port role elections. Now nothing more than. There is no root port on device A. Instead of having one and only one root port on the root device. That is. There is a root port between device B and device C. There are only 2 ports on device B. There are only 2 ports on device C. Both device B and device C need to receive data from their own 2 ports. Choose a port to be the root port. That is, these 2 ports in device B. One must be the root port. There must be a root port in device C. We will compare parameters. First let's compare the first parameter. It is called the root path cost in the inbound direction. This value is what we call RPC. Is the root path cost. We're going to compare. The smaller the comparison value, the better. When we compare, no matter what role is elected, all parameters are all smaller values are better. The comparison of almost all parameters in the second layer is that the smaller the better. In almost all 3 layers, the bigger the better. For us now, let's look at device B. Compared with device C, it is actually the same. Let me identify the interfaces of these devices. For example, this is the B1 interface on the left. This is the B2 interface on the right. Then the device C interface here. This is the C1 interface. This is the C2 interface. We are now going to select an interface in B1 and B2. Become a root port on device B. When we compare. In fact, it compares the cost of the root path in the inbound direction. The root will send messages to the outside world, which is then forwarded by the non-rooted device. That is, device A only needs to become the root bridge. All future BPDU messages will be sent by this device. Device B will receive such a message from the interface B1. The inbound direction refers to the inbound direction of the BPDU packet. If received from B2 interface. That's how the message came. What we are comparing now is the root path cost in the inbound direction. Then, for B1, its overhead is the overhead of this interface. For B2, its cost is B2 plus C2. That is, on device B, when comparing 2 interfaces, actually received by this B1 interface, assuming each counts as 1 first. We just calculate as an example. Because the default is the same. It is 1. 2 on the right. What we compare is the root path cost in the inbound direction. Then here comes a message. Only through one interface. Is 1. We calculated this when we calculated EIGRP before. The truth is the same. When packets come in, there are two interfaces. This is 2. If device B above, the RPC of the B1 interface is 1. B2 interface RPC is 2. We take a smaller value. Then this interface is good. The B1 interface is selected as the root port. But I want to ask, is it possible that I did the comparison and it didn't come out? Will there be such a situation? Okay. There is such a possibility. Some students may think, it seems like it should all be consistent by default. Let's draw a new picture. I now draw one more device. It is easier to compare, even if all its parameters are default. You will find it will also have some problems. I connect them. Now that's 4 devices. Let's say this is device A. This is device B. This is device C. This is device D. Suppose device A is still root. Device A needs to periodically send messages to the outside world. So where do we choose the port on this device now? We choose on this device. When device D makes a selection, which of the interfaces on the top and the left will become the root port? Let's take a look at a path it takes when forwarding. Device A now sends BPDU messages to the outside world from both interfaces. This message is sent to device B here. Send from device B to device D. Arrived at the interface of device D. Same. The packet sent by device A passes through device C. Also sent to device D. So now when device D is comparing the cost of the root path, how should the two interfaces be compared? It is now compared to this interface plus this interface. Assuming the default is 1. It is 2. Then received from the left interface. It is from the interface of device C plus the interface of device D. This is also 2. You will find, if we only compare the cost of the root path, it may not be comparable. That is, the root path cost received by device D from the two interfaces is 2. If this is the case, we will definitely not be able to compare. We will have a second parameter. The second parameter compares the bit of the upstream device. That is, forward bridge ID. The uplink device is the device that sends this message to you. For example, device B sends a message to device D. Device C sends a message to device D. Both device B and device C are called uplink devices of device D. If the RPC can't compare now, I will compare the bridge ID of the upstream device. In fact, the comparison is their priority plus MAC address. Is it possible that the bit of the upstream device is the same? Can you draw such a topology in your mind? In our picture, it is inconsistent. So if a picture like this, in fact, it can be compared. But the reality is often not so easy. We have other possibilities. It's just that I can't compare RPC now. The bridge ID of the upstream device still cannot be compared. What's going on? I'll draw another picture to explain. For example, we only have 2 devices right now. I'll make a redundant circuit for it. I want to run 2 wires between 2 switches. The above is the root. This is 001. This is 002. So now let's compare. Suppose the following is device A. I choose the root port for device A. Let's first compare the root path cost in the inbound direction. The default is 1. Can't compare. Okay. Then compare the bridge ID of the upstream device. Now I found that the uplink device is only this one. If there is only one upstream device, then there is no way to compare. But we still have the port of the above device for comparison. Now although the upper equipment is the same, the device bid is the same as, but there are always differences on the device. For example, The two interfaces of the device are different. Then I just said 4 PID itself is the priority of the interface. Of course it is also equal by default. But the port numbers are inconsistent. So I will now do a third comparison.